In this problem, we're asked to find the smallest prime factor of the sum 13 to the 13th power plus 17 to the 17th power. And the key to this one is to recognize that whenever we take an odd number times an odd number, we get an odd number. Okay, so that means that 13 to the 13th power, that's just 13 multiplied by 13 times. We're just taking odds times odds, and so we're always going to get an odd number. So 13 to the 13th power is odd. And the same way for 17 to the 17th power. It's also odd because we're just taking 17 times 17 times, and all the odds are multiplied by odds, and we get an odd. And then if we have an odd number plus an odd number, we're going to get an even number. All right? And an even number has to be divisible by 2, right? So that means that the smallest prime factor of the sum is 2, right? Because that's the smallest prime of all. And it might be worthwhile to note, too, that 1 is not prime. So if you got the answer of 1, 1 is not a prime number. Now, obviously, 1 is smaller than 2, and it divides that sum, but 1 is defined not to be prime. And the main reason I think, as far as I can figure, is because of the fundamental theorem of arithmetic. Or sometimes it's called the unique prime factorization, let's see, fundamental theorem of arithmetic. Or like I started to say, it's also called sometimes the unique prime factorization theorem, okay, and which is a lot more descriptive. It just basically says that for all positive integers greater than 1, there's a unique prime factorization. So if 1 were defined to be prime, then we could take a number like 14. Now its prime factors are 2 and 7. But if 1 were also prime, we could say 1 times 2 times 7, or 1 times 1 times 2 times 7, or 1 times 1 times 1 times 1 times 1 times 2 times 7. So we wouldn't get a unique prime factorization if 1 was prime. So, to make our life easy, we define 1 not to be prime. Okay? So, the smallest prime factor that divides the sum is 2.